Okay, so we've all heard the word cancer, right? And it's a heavy word. But have you ever really stopped to think about what's actually happening? How does a perfectly normal, healthy cell in your body just go rogue and become something so dangerous? Well, today, we're going to peel back the layers of that mystery and look at the step-by-step process of how cancer begins, a process called carcinogenesis.
We're always hearing, avoid this, it's a carcinogen. Don't eat that. But what does that even mean? What are these things actually doing inside our bodies down at the microscopic level? How does touching something or breathing something in lead to a tumor? That's the mystery we're cracking today.
All right, so first things first, let's just get on the same page with a couple of key terms. Carcinogenesis, that's the process, the actual playbook for how a tumor gets made. And the carcinogen, that's the agent, the bad guy that kicks the whole thing off. Okay, simple enough. Now let's meet the suspects. So when we start digging into what causes cancer, it turns out the culprits pretty much fall into three main gangs. You can think of them as having three different MOs: the chemical agents, the physical forces, and the biological hijackers. Let's take a look at how each of them operates. All right, let's dive into that first one, the chemical attack. Now, these are probably the ones you've heard about the most. We're talking about substances in our environment, our food, maybe even stuff we use every day that can kickstart the cancer process just through direct molecular interaction. And what's really wild here is that these chemical bad guys have two totally different ways of operating. You've got your direct-acting ones. These guys are ready to go from the second they get in your body. Think of them like a bull in a china shop, just immediately starting to damage your DNA. But then you have the sneaky ones, the indirect-acting carcinogens. At first, they're totally harmless. But, and get this is the crazy part, our own liver, in trying to do its job and clean house, can accidentally flip a switch and turn them into something dangerous. It's like our body's own defense system gets tricked into helping the enemy. And we're not just talking about some weird chemicals you'd only find in a high-tech lab. No, this is stuff we can run into all the time. You know that nice char on a grilled steak, or obviously cigarette smoke? Both have chemicals called polycyclic aromatic hydrocarbons, or aflatoxin. That's a toxin from a fungus that can grow on crops like peanuts. Even things like asbestos, certain metals, and some pesticides can be these chemical culprits. So how does this chemical attack actually play out? Well, it happens in three stages. First up is initiation. This is the first hit. The chemical scores a direct hit on a cell's DNA, and boom, it causes a permanent, irreversible mutation. Next is promotion. This is where the fire starts to spread. Another agent comes along and basically tells that one mutated cell, hey, you should start copying yourself a lot. And finally, you have progression. This is the transformation, where that growing group of mutated cells starts to look and act like a full-blown malignant tumor. So it's really, really important to get the difference between an initiator and a promoter. The initiator is like the spark that starts the fire. It's a one-and-done deal, a permanent change to the DNA. But the promoter, that's the gasoline you pour on the spark. It doesn't actually start the fire, it doesn't damage the DNA, but man, it makes that fire, those mutated cells, just grow completely out of control. Okay, so we've covered the chemical arsonists. Now let's move on to our second group of suspects, the physical assault. Here, we're not talking about substances you can touch. We're talking about pure energy, physical forces that can do just as much, if not more, damage. And the two main players in this category? Radiation. First, you've got UV radiation from the sun. Now, it's not super powerful, so it can't go deep into our bodies, but it's more than enough to mess with the DNA in our skin cells. What it does is create these little kinks in the DNA, almost like a typo in the code, that makes it really hard for the cell to read its own instruction manual. Then you have the heavy hitter, ionizing radiation. We're talking X-rays, radioactive stuff. This is way, way more powerful. It doesn't just create a kink, it can literally blast right through your body and shatter your DNA like a wrecking ball hitting a window. And this is a perfect example of how the how determines the what. So that skin deep damage from UV light, well, that's linked to skin cancers like melanoma. Makes sense, right? And the deep penetrating power of ionizing radiation, that's linked to cancers deeper inside the body, like leukemias or cancers of the thyroid and lung. But hold on, it's not just about radiation. Even something as simple as chronic physical irritation, like, say, the constant inflammation that asbestos fibers cause in the lungs, or what gallstones do in the gallbladder, that constant prodding can encourage cells to divide more often, which just raises the chances of a mutation happening and leading to cancer. All right, on to our third and final suspect, the biological hijack. This is where living things, mostly viruses, actually invade our cells and basically turn them into traitors. And listen, the proof that some viruses can cause cancer, it's rock solid. We see these direct lines. HPV is the #1 cause of cervical cancer. The Epstein-Barr virus is linked to a type of lymphoma. Hepatitis B and C can lead to liver cancer. These viruses are a huge deal in the story of cancer around the world. But you gotta wonder, how does a tiny little virus pull off something so devastating? I mean, its goal isn't to cause cancer. Its goal is just to make more viruses. So what's going on here? Well, when one of these DNA viruses infects one of your cells, it's like a fork in the road. There are 2 ways it can go. Path number 1 is replication. The virus turns the cell into a little virus factory, churns out a ton of copies of itself, and then pop! It bursts the cell to set them all free. The cell dies, end of story, no cancer. But then there's path number 2, the more sinister one, integration. Here the virus decides not to make copies. Instead, it does something wild. It literally splices its own genetic code right into your cell's DNA. This creates a permanent mutation, and that is what can mess up the cell's controls and send it down the path to cancer. Okay, so we've looked at 3 completely different gangs of culprits, right? Chemicals, physical forces, and biological hijackers. But now, it's time for the big reveal. The one thing that connects all of them. So think about it. We've got a chemical attack that tweaks a tiny piece of code, a physical assault from a ray of sunlight, and a biological hijack where a virus inserts its own blueprint. I mean, these are totally different methods of attack, coming from completely different places. But here's the absolute key. They are all aiming for the exact same weak point in our body's defenses. And that weak point is our DNA. It doesn't matter if it's a chemical, a blast of radiation, or a sneaky virus. The endgame is always the same. Damage the cell's genetic blueprint. This is it. This is the central event, the one thing that has to happen for cancer to even begin. And get this, it's not even random damage. It's not like they're just swinging blindly. Carcinogens are more like expert saboteurs. They go after the most critical parts of the cell's operating system, specifically the genes that control growth and death. Think of it like a car. Some of your genes are the gas pedal, telling the cell, go, divide, grow. Other genes are the brakes, telling it, whoa, okay, stop now. What these carcinogens do is they either jam that gas pedal to the floor or they just go ahead and cut the brake lines. Either way, you get out of control growth. And a really important thing to remember is that this almost never happens overnight. As our source material points out, this whole process is a long game. It's a multi-step thing that can take years, sometimes even decades, to fully play out. It's not just one hit. It usually takes multiple hits to the DNA before a cell truly goes off the rails. So, what's the big takeaway here? Why does all of this matter? It matters because when we understand the how, the exact ways these different agents all end up damaging our DNA, we can get so much smarter about preventing it in the first place. And for treatment, we can design smarter, more targeted therapies that actually go in and interrupt this exact process. You know, they say knowledge is power, and when it comes to fighting cancer, knowing the enemy's playbook is the first, most critical step to winning the fight.